All right, we're back. So we left off talking about mean and median, and we mentioned how the mean is very much impacted by an extreme value. That's one of the benefits of the median. It's not. Well, the mode is the third measure of central tendency, and it's the least mathematical of any of them. Basically, look what it says. The mode is sometimes said to be the most typical case. So we've got mean, which is a mathematical average, median, which is middle, and mode, which is most. The value that occurs most often in a data set is called the mode. And again, I know you're thinking that doesn't sound very mathematical, but averages tend to behave like that, right? There's a reason why certain things are average. They appear the most, okay? That's what makes them average. Data set can have more than one mode or no mode at all. Okay? So, here's a data set talking about the duration of U.S. space shuttle voyages from 2002 to 2008. Find the mode. Well, I'm thinking in this situation, and you know, if there's more data items than this, it's often valuable to go ahead and put them in a frequency distribution so you can actually see it without trying to remember. So that's what we did here. So here's a frequency of that, and now I can easily see that 13 days is the mode. It shows up the most. That's all there is, okay, for the mode, which one shows up the most. Here's another one. 6 strains of bacteria were tested by the Centers for Disease Control. Boy, is that appropriate, huh? To see how long they could remain alive outside their normal environment. The time in minutes is recorded below. Find the mode. Well, I'm looking here, and I don't see a number that shows up more than any other numbers. It's not the largest number, okay? It's which number would show up the most. And this one has no mode. This one has no mode. This data set. Because this is minutes, so no minutes recording shows up more than any others. Okay, there you go. How about this? Number of wins in a 16-game season for the Cincinnati Bengals from 97 to 2008. And, all right, we're going to try to do this without a frequency distribution. And I think I see 4 showing up. 1, 2, 3. Oh, there's 8 showing up 3 times. Okay, so this one is actually what's called bimodal, meaning bi for 2, 4, and 8. Now again, that doesn't really mean much. It's a small data set, but it just is what it is, okay? That's the mode. The mode is, don't average them or anything like that, just report them. Okay, the modes are 4 and 8. Okay? The last one is called the mid-range, and it's the least, I don't want to say it's the least accurate, but it is very, very influenced by extreme values. Because look at what it does. It adds the lowest and the highest, and it averages them. It divides by 2. Well, that's taking the 2 extreme values and then averaging them. That typically, the more data involved, the better the statistics. But the mid-range is simply the average of the high and the low value. It's just a quick, easy to calculate, and it's one more average that does get reported sometimes in a research study. Okay? So here we go. Number of deaths. Oh, I guess we're back to that morbid example. We've got 12, 6, 2, 1, 3. Well, I guess not morbid because they were set free, right? So that's good. So we want to find the mid-range. Well, the mid-range would be the low value plus the high value divided by 2. Well, that's kind of an odd number again, right? 6.5 doesn't even make any sense. But that's what the statistics is. 6.5 is the average, the mid-range. Okay? All right. So here's just a couple things that I think you'll find interesting. It's kind of strengths and weaknesses of each measure, okay? And sometimes being a wise consumer, you can kind of tell when one ad is reporting an unusual claim, you think, I wonder what average they're using for that. But you can just read through these. This is just for you to be informed. Okay, I'm not going to test you over something like this. And we've already seen this, right? The mean can be adversely affected by one or two high or low scores. That doesn't happen as much with the median. All right, let's transition from finding just averages, because people don't normally just care about an average. Like if I gave a test and I said, hey, the average was an 82, you're like, yeah, but I want to know my grade, right? Where did I fall in that situation? Am I above, below? Am I better than average, less than average? So ranking and position are often very important in statistics. And we're going to go over that in the next 10 or 12 slides, I guess. Okay? So two important measures of position are percentiles, and maybe you've heard some of these words before. Percentiles and quartiles. Like when you take the SAT, ACT, it'll say, hey, you're in the 68th percentile. Well, maybe you never knew what that meant. Well, hopefully you'll have a little bit better idea after these next couple sections. Okay? All right. So percentiles. Just like on a test is divided into 100%, 100 individual units. And if you got a 98%, you got 98 out of 100 points. Well, it depends on what we're measuring, whether or not it's going to be points or something else. Okay? But that's what, when you see the word percentile, think about 100 equal parts. All right? This is important when you go to, we'll use this a lot in the next couple sections, but a score in the nth percentile, okay, means that you outperformed about n% of the population who took the test, okay? So you got to interpret this right. So when you get notification that you were in the 85th percentile, it does not mean you scored an 85 on the test. Okay, what it does mean is that you scored better than about 85% of the people who took the test. Okay, that's pretty good. You could also say that about 15% scored higher than you, but normally it's reported in the first, it's understood to be the first number. That's how it's typically thought of, that you scored better than 85%. Okay, that's percentiles in a nutshell. It's just that percent is not your score. It's what percent of the population you did better than. Okay? All right, quartiles. Now, a quarter is 1/4, right? So quartiles breaks the data into 4 equal parts. Percentiles broke it into 100 equal parts, but this breaks it into 4 equal parts. All right? The first quartile is the value that is higher than about 25% of the population, quartile 1. Okay. We're going to actually look at quartile 1, 2, 3, and quartile 1, 2, and 3. You'll see why. The second quartile is a value that is higher than about half. The second quartile is also the median. It's kind of interesting because remember, we're talking about positions. Talking about positions. So the median also is a position number, right? Order the data and look for the one in the middle. That's also called your second quartile. So you already know how to find that. And the third quartile is the middle of the top half. Okay, and I'll show you a picture that'll help you in a second. If you're on the third quartile, then you would say that whatever that's describing is higher than about 3/4 or 75%. The third quartile is the same as the 75th percentile. Okay, let's take a look. This will help. A picture is worth 1,000 words, right? So here we go. So quartile 2, this is the median. And quartile 1 is the middle of the lower half. Okay, so here's the bottom half. And quartile 1 is the middle of that. And the upper half, quartile 3 is the middle of that. Okay, quartile 4 doesn't really make any sense because it's up here, and obviously it's above everything. It's at 100%, so there's nothing above it, and everything is below it. So it's kind of silly. Everybody knows what the fourth quartile is. It's the top of the data set. Okay, so all we're doing is finding middles. Okay, so 25% are below this number. If say they took salaries, they came into your workplace, and well, HR knows this, and they ranked all the salaries. Okay, well, if you were at the quartile 1, that would mean that 25% of the employees make less than you. If you were at quartile 2, that would be 50% are below you. And if your salary was the third quartile, right on it, then 75% are below you. Make sense? Okay. Obviously, if you were at the top, well, then you know everybody's below you. I mean, 100% is below you. All right, so try to keep that in mind as we work through this. It'll make a lot more sense if you think about it in terms of percents as far as locations. Okay? Okay. So let's go ahead and let's determine how we find quartiles. And it's almost like finding the median. You start off the same way. So order the data from smallest to largest. Okay. And then we'll start with the median, because that's the one we're most familiar with, the second quartile. And if it's odd, then it will be the middle value. And if it's even, then we have to average the two closest, like we did before, right? So we can handle that either way. And then quartile 1 is the middle of the lower half. Again, think about it in terms of top half, bottom half, right? Quartile 1 is the middle of the bottom half, right here. And quartile 3 is the middle of the top half. So quartile 2 splits it into two different halves, upper half and lower half. And the quartile 1 and quartile 3 are just the halves, top half, middle of the top half, middle of the bottom half. All right, team? All right. And like I just said, quartile 3 is the middle of the upper half. All right. And there's that picture one more time. All right, I think we can, let's go work this out. I think we got this. So what do we've got? Electronics World is concerned about the high turnover of its sales staff. A survey was done to determine how long in months the sales staff had been at their current position. The responses of 17 sales staff follow. Find Q1, Q2, Q3. All right. So here we go. Here's all the data right here. So the first thing we do is we organize it, right? We're going to rank it from smallest to largest. And that's what happens down here. 3, 5, 6, blah, 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 blah. Smallest to largest. Okay? So first quartile we find is quartile 2. Now just remember, quartile 2 is the median. Okay? This is the median. So the best way I can think of to find the median is just to start crossing out data from both ends and work your way to the middle, right? So cross out that one, 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 and there we go. 12. 12 is the median. So that means, what are we talking about again here? We're talking about how long people have been on at their job. Okay, so half the employees have been there less than 12 months and half have been there more than 12 months. So about a year is average to be at this job, about a year. And that's the kind of information that employees like to know, employers like to know. Okay, all right. All right, so while we're here, looks like I lost a slide here. Well, I guess we're going to find the other ones too. We might as well just do it from right here. Kind of odd. Okay, so the bottom half, okay, so 12 was used, okay, so this is the bottom half of the data. That's down here. Okay, well, Q1 is the middle. All right, so Q2 is 12. Let's go ahead and let's find Q1. Well, do the same thing we just did, but with a smaller group of numbers. Let's find the middle of the numbers in the purple box. So cross these out. And I'm stuck with 2. So what do I do when I have 2 middle numbers? I have to average them, right? So let's average. It's going to be 7 plus 8 divided by 2. So what's 15 divided by 2? 7.5. Okay? So 7.5 is your Q1. It's the middle of the lower half. It's the middle of the lower half. All right? Well, let's go and let's now find Q3. We'll get this out of the way. Leave 12 crossed off because 12 is the middle, so we don't want to use him again. Okay? Once a data point gets used, you don't use it again. So now this is the upper half, and this is the upper half. So Q3 would be the middle. So let's cross them out and work our way to the middle. And once again, I have 2 numbers. So Q3 is 17 plus 18 divided by 2. And what you get, is that 35? 35 divided by 2. And what you get for that? 17.5. Very good. So Q3 is 17.5. And that's how you do it. You're just doing the median 3 times. So Q2 is the middle of the whole data set. Q1 is the middle of the lower half, and Q3 is the middle of the upper half. Now let's go back over what these numbers mean. Okay, this was number of months people have been at the job. Okay, so this tells me that Q1, this tells me about 25%. Okay, less than 25% are at this job 7.5 months. Okay, you could say that here's another 25%. 25% are there between 7.5 and 12 months. Q3 was 17.5. And at Q3, remember, that's 75%. So 75% of the people that work at this place have worked there less than 17.5 months. 25% have worked there more than 17.5 months. Okay? So it's just quarters and halves and just interpreting it in terms of the whatever the data set's talking about. Okay? Well, friends, I think that's it. This one, I feel like there should have been, maybe I should have had Q3. I guess I could have done Q3 or Q2 and Q3 here, or 1 and 3 here, and then that slide wouldn't have been so crowded. But anyways, I hope it makes sense. Send me an email. Let me know if I can help you with anything. I hope you're doing great. Have a good week. Talk to you soon. Bye.